afternoon. Hope you're all comfortable. Hope it's not too hot. It's hotter up here. Actually, this title once had a question mark in it. I don't know where it got dropped, so it's a service mesh magic with a question mark. The purpose of this talk is not to spread magic or talk to you about magic. It's actually more the opposite. It's cutting out the magic of this service mesh hype a little bit. And my experience is for cutting out the magic, the best way is to explain what it really does. And the second part is how do we do, well, what we want to do with a service mesh. So this is what this presentation is about. So my name is Frank Munz. I work for AWS as a technical evangelist covering the German-speaking countries, Germany, Austria, Switzerland. And let me start with a semi-rhetoric questions. If you build a modern application these days, what is the typical building block? And I told you it's kind of semi-rhetoric because probably somebody in the back already said containers, isn't it? That's why we're here now. It's ContainerDays. Containers. That's it? What else? Guys, come on, it's not that hard. Is it? Yeah, microservices, but how do you run your microservices? What's the technology behind? Yeah. How about serverless? I have lots of colleagues that tell me, Frank, what you're talking about containers will be gone very soon, and what they would do with 80% of all use cases is just make it serverless. So serverless, like in function as a service, like in AWS Lambda. Are these all the options, all the modern options that we should consider? How about all the other cloud services that we have these days? And it goes back to the question, like people come to me and say, should I run my MySQL instance in a Docker container? Or should I not do that? And I tell them I have no objections if you want to run your MySQL in a Docker container. If you find it useful and quick to do, there is no reason why not to do it. If you tell me that you're planning to deal with like 64 terabyte of data and you want to have 6 copies of your data across 3 availability zones and maybe across regions, and you want multi-master, and you want snapshots in time and restores and all this, then I would say we're looking for software engineers, so you're welcome to send us an application. And that's probably not what you should try to do yourself. So the thing is, you don't stuff everything in a container. So we have those options, containers, serverless, and all those, in our case, 165 different cloud services. Is that it? Well, it's almost it, and there is still the classic compute around, which is EC2. So there will be cases where we still go back to classic compute. And let's just keep this in mind for a bit, and I come back to this later. So the presentation is built in a way like I'm trying to introduce a couple of different things, and then we put them together to get a better understanding of what we're doing. So you all know that running a Docker container is not enough now. And I confess guilty of, being on stage and telling people, look, it works on my laptop and you can easily scale it. And what we typically do is we have this little bash loop that starts like 300 containers, and you say, look, this is cool. This is what the big ones like Amazon and Google and all the others do. But it's not a true story now. What you really want is you need to deal with all this complexity of having a lot of containers because they come and go. Running containers across different machines is itself a challenging task, so it's not something that you can easily do. And we should not forget it's not virtualization. No, it just looks like virtualization. It's a little bit of these C groups and namespaces that makes it look like a virtual machine, but it's not. No, at the end, it's just a process running next to many other processes, and if you're root on this machine, you can do whatever you want, and if the machine has a problem, you need to deal with these containers and make sure you migrate them somewhere. And obviously, there is a solution for it. So it's not enough just to start like 100 containers in a loop. You need some orchestration behind it. And you all know there is something I'm going to talk about next, but first of all, in our case, there's something called ECS, which is the Elastic Container Service, which is not Kubernetes. So there was a time when we understood that running several containers is not good enough and we needed some orchestration, but there was also not Kubernetes around, or at least it was not there in the majority level that most people wanted to use it. It was pre 1.0. So if you want to start today with containers on AWS, still the easiest way to do is use ECS and not Kubernetes. And I'm saying you this despite I'm a big Kubernetes fan now. I like all these benefits that we have from Kubernetes. But if you want the best integration to other services, to monitoring, to everything else, if you want to scale to super large clusters, and if you want service integration at this container level, ECS is the easiest way to go. But then we have Kubernetes now. So we built ECS, and the question is, well, this could actually almost be the end of the presentation now, because that's the maybe easiest default way to run Kubernetes. So the people like Kubernetes. If we speak to people, what they say is, we understand the complexity of Kubernetes, so we tried ourselves and we failed. I mean, I tried it myself. I built a little Kubernetes cluster, and I had a strong Docker background and a strong Linux background, and I thought it must be easy to run on a small scale, Raspberry Pi cluster Kubernetes. And I miserably failed, to be honest. Like it took me so much time that at the end, I realized it's not really worth my time. So what we very often hear from customers is, well, we want Kubernetes, but we want you to run Kubernetes. And that's a message we hear in different ways. So they say, well, give us a service that does Kubernetes, but don't change it, don't add bells and whistles, don't fork it, leave it upstream, make it upstream compatible. But altogether, the understanding is that running Kubernetes yourself is really hard. I know there are some companies out there, and some of you might be one of those companies that have a super strong Kubernetes knowledge, and you're doing this as a daily job, and that's fine. But for most customers, this is not applying. Ask yourself the question, who are the 3 people that you call at a Saturday night at 11 o'clock if something goes wrong? It's not that you don't figure out the right kubectl command. It's something really goes wrong and you need to debug it. Who are those people that you could call? Okay, so at the end, we have this EKS service. Despite having the ECS service already, we have an EKS service that gives you, well, it gives you a managed Kubernetes backplane. You bring the worker nodes that are visualized here. We manage the backplane. The backplane is highly available. It's provisioning at CD in a scalable way. We give it provision throughput, we snapshot it, we restore it if something goes wrong, and you basically get a fully qualified domain name and you connect to it. You bring your own worker nodes, which some people like because you can have spot instances, you can put them in an auto-scaling group. Windows is better now. You can have instances that come with a GPU. A lot of people say, why would you want to have worker nodes for Kubernetes with a GPU? But you'd be surprised how many machine learning workloads are running on top of Kubernetes these days. So you have all this flexibility. And at the end, you connect it to the backplane and you use your standard tools like kubectl. So we have those 2 options, and we have all those building blocks that I kind of listed at the beginning. And the question is now, why would we go for a service mesh? And the following is a diagram that when I saw it, it was like, wow, this is exactly what I was looking for a long time ago. It's from an InfoQ article, and it starts with the old world of service-oriented architecture. Do you remember this time when it was like pre-microservices, when we talked about SOA? In this SOA world, if you did it right, you didn't just connect your services, like every service to every other service, like what you see here. If you connect them all like point to point, you get a squared complexity. That's not what you want. That's actually as bad as it gets now. So we always had this idea of having a service bus in the middle for integrating those services. And the key idea of the service bus was that it exposes the API of the service. You talk to the service bus, and the service bus is then forwarding the request to the service. And actually, this was not so bad, I would say. I know there's many companies that say, no, I don't want to do service bus project. But we had very successful projects using this kind of service integration technology. And sometimes we call it even service virtualization layer. It's also something to keep in mind. One of the issues is it's a big monolithic thing. And we have this trend from going from monolithic endpoint that expose an API to lots of endpoints that are microservices. Now, if you go from this big monolithic, if you still have this big monolithic service bus and you have a lot of small endpoints, the question is, does it really work together? Isn't there some kind of impedance mismatch? And that wouldn't be the biggest problem, but there were some smaller problems, like this service bus typically is working configuration driven. So if you change it, if you change the configuration and you decide like a service A should route to a service C instead of B, usually this would work by configuration and you didn't have to restart it. Now the question is, what is this usually it would work? What would ops people do if you tell them usually it works without restarting? Well, they restart every single time. Now, if you have this big monolithic thing in the middle and your small services, but you need to restart the connection between them all the time, it doesn't make a lot of sense. So the question is, couldn't there be something more useful, more up-to-date? And today we have this microservices world. And the question is, all this functionality, all these cross-cutting concerns that we had in the service bus, like where you decide where to route to a message, because it's a big thing in the middle, it's a perfect place to do monitoring, it's a perfect place to apply security, it's a perfect place to get all kind of telemetry data. How else could we achieve this? Now, do you remember the time when those Netflix libraries were super popular? Like, I remember job ads where they said, you know, we're looking for a developer, but you have to know the Hystrix Netflix library. They tried to solve the same problem by adding a library to your microservice, which, first of all, is not this big monolithic thing anymore. So it sounds better. The disadvantage is that those library, it exists for one particular language, which kind of limits it a little bit. But the much bigger impact, in my opinion, is tell somebody to get a software project to the cloud. The best way to do it is use the library. That means you need to change your code and include the library. So for going to the cloud with a successful project, you need to change your source code. That's a bit weird and challenging at the same time. And looking back at the service bus, it had its disadvantages, but at least it was language independent, and you didn't have to change your source code. No, you just pointed to the service bus, and the service bus would forward it then, and it would do all the magic. Now, the real question is, couldn't we have the best of both worlds? And the answer is yes, we can, and that's actually the service mesh. So with the service mesh approach, we have small proxies. They're not part of the microservice, but they live in the same pod if you talk about Kubernetes. And those proxies implement the same functionality, but they work on a network level, actually on a level 7 network level. And this is why they're language independent, and you don't need to change your code. So it's a benefit of both approaches, and that's why I like this diagram a lot. It's actually from a colleague from Roland who's sitting here. They're the two guys who wrote the Kubernetes patterns book, which I also recommend. And well, you see, this is you have the link. I think we should always give references to people who create great diagrams. It's a great article also to read about, well, how this all evolved. So that's the key approach. No? That's what we want to do with a service bus, and that's the example. The most prominent example these days is Istio and Envoy. It's a couple, and the proxy is the Envoy proxy. And as you see here, this Envoy proxy lives in the same pod as the client. So this prod page wants to talk to the reviews page, and the real communication is going through the proxy. The proxy is in the same pod. They share the same network namespace, and together with the configuration of the proxy, it's possible that the proxy is intercepting all these calls. And then we have the same situation that we had for the service bus. Now it's the thing in the middle where you can get all the telemetry data. And getting the data and configuring this is done with the control plane, and that's the Istio part from Istio and Envoy. So it seems like a married couple, this Istio and Envoy, and it's probably the most prominent example from the open source world. And now you can do some kind of magic. Now you could do something like, if you just apply this little YAML file, you can say, if you want to talk to a review service, like 80% of the clients go to version 2, and like 20% go to version 3. And you could make this 99 and 1 or 97 and 3%. And obviously the interesting thing is that you can gradually shift your traffic. And that's just one of the things. You can introduce error codes between those proxies. You can introduce security. So there's a lot of functionality, very similar to those cross-cutting concerns that we had in the earlier days in this SOA world. And all you need is the kubectl apply from this YAML file. Right, and this kind of brings me back to a more basic questions. How do you update a complex software project? Because that's another kind of illustration where this is working really well. And this is a diagram that I picked from Martin Fowler. And he's talking about those blue-green deployments. And in very early days, like pre-cloud, if you had a blue version and you needed to go to version green, and I did a lot of these consulting projects where you spend like weeks in planning, and then they ask you like, how should the hardware for the blue version look like? What do we invest if we predict this kind of load increment for the next year? And then you basically double your hardware. So if the hardware costs you $1 million, you double it and you spend another $1 million, and then finally you take this big switch and you flip over and you change to the version blue, which is a big risk, because if version blue is not working perfectly well, you want to switch back. Now you probably say, come on, this is ContainerDays and we work with Kubernetes. First of all, you don't buy the hardware because you live in the cloud. I already told you there's many reasons why you should do Kubernetes in the cloud as a managed service. Second of all, if you do Kubernetes, you could do, most of you know, a rolling update of your services by just redeploying the service. If you do this, and let's assume you have like 10,000 customers and you spread the load across 4 pods that are running for throughput reasons. And if you do a rolling update, you change from, one pod goes from blue to green to the second one. So it's like 25, 50, 75, 100%. It's still a lot of, traffic change. And if you have 10,000 customers, it would be like 2,500 use this version, 5,000 use it. And again, you have to be super careful. So the question is, why not just shifting the traffic and making this independent from the pod deployment or from the pod versioning? And this is what you can do with a service mesh. So yes, Kubernetes can do rolling upgrades. Yes, I know you can even do this with Docker Swarm. When I terribly failed with my own little Docker cluster, I realized how nice Docker Swarm is working these days. And they all can do these rolling updates, but they cannot do this traffic shifting like 3%, 5%, 7%, or introduction of errors, like working on this network level. This is where the service mesh is really good at. So if you want, you can run Istio and Envoy together on EKS, on the managed Kubernetes service. And again, this could be the end of the talk because it's just so hot now and we could go for drinks. I did a talk like this and I demoed Istio and Envoy on EKS, and people were quite happy. That was at a time before you asked us for more. AWS is a company that really carefully tries to listen what customers want. So maybe 90% of our roadmap is driven by customer feedback. And customers said, couldn't you build a service mesh for all compute services that you have? Now, you probably realized why I asked you this question when we started. And the answer is yes, there is one. We built it. It became GA in March, end of March. And we already listed all those compute services. So it's basically ECS and EKS. For ECS, there's 2 versions. One is where you bring your own worker nodes, and one is a serverless way where it's called Fargate, where we provision the worker nodes. You don't even see them. You just give us a task specification. You say how much RAM and CPUs you want, and we run your containers. That's the serverless way of doing containers. That's ECS. With Fargate or without Fargate. Then it's EKS. It could be actually EC2 only that you can also use. So it's not necessary that you have containers to use the service mesh. Or it could be your self-hosted Kubernetes on EC2, if you have the operational skills to run Kubernetes yourself. And all this together, you can use App Mesh. That's the big news now. That's the thing why we built App Mesh. Now, you're probably saying, so you spoke a lot about Istio and Envoy, and now you tell us that you did something completely different. The good news is, and when I was watching this, what is happening, I was really curious about what will really be the core of the implementation of this app mesh product implementation. The good thing is we took Envoy, so the motor that is really doing all these connections that you need to instrument somehow, where you can get the telemetry data. The thing that is connecting the services at the end, it's Envoy. And we took Envoy, but because we wanted to apply it to all possible compute services that we have, we built an own app mesh around. So it's not Istio with Envoy. That seems like a married couple. They're not so tightly married, so sometimes they do different things. So app mesh is the own service mesh that we have, and we use Envoy as a core, as the motor, as this proxy. And well, you can use it like all the other things with an API, start with the console, start with the command line. There is no charge for it, so if you want to use it, you can use it for free. It's just the resources that you use for it. The thing is, a lot of people say, I'm already struggling with Kubernetes, so what's the best way to get started with this app mesh thing? That's why I have some more slides for you. And my first recommendation is, I mean, if you set up something for production, you want to have more details, for sure. But if you want to play with it, and that's the entry level, and I'm a person that always wants to see what's the minimum thing I need to do to get this up and running. So if the minimum thing that you want to do is play with app mesh, create your Kubernetes cluster with the managed service that we have with EKS. There's a great open source tool out there. It's called EKS Control. And all you do is you say EKS Control, create cluster. Well, you install the tool, first of all, but then you create a cluster. You have the EKS cluster running, and you can give it a name. You can give it the -- app mesh access that already sets the right policies, so app mesh can access the resources. And then what we have now is it's more a demo. So again, that's not the production installation, but we have a Helm chart. Helm is like a package manager for Kubernetes. And with this Helm chart, you can install the app mesh. And it doesn't only install the app mesh, it also installs a mutating webhook admission controller, which basically is the magic to inject those proxies into your pods. And it's not only injecting the Envoy proxy, it also gives you the statsd Prometheus exporter, and it gives you the connection to our own system, to AWS X-Ray for monitoring. So all these we inject at the same time. Which also means if you create a pod, if you have some service running, you will see four containers in this service. And that's just for demo. That's why I'm saying that's not really production. But the cool thing now is you can do it with a single Helm chart. And then we have a small demo. It's actually a load-generating script that is talking to an Nginx container. And again, this is in a Helm chart. What you do first is say kubectl create namespace app mesh, and then you deploy this into this namespace. And the interesting thing is that we label the namespace, and that's the way these app meshes work. You label the namespace in a way that you say this injection should be enabled. So if you run a pod in this namespace, you always get those extra sidecars injected. That's the magic. This is how this webhook is working. And then the last line is basically installing the demo, that is this load generating script that is talking to Nginx. And here you also see the URL. I'll have the slides online on Speaker Deck already. You don't need to take photos. A colleague of mine did this, Paul Maddox, so he gets all the credit for this little demo. So it's 2 steps basically, and you have this up and running, and you can play with it. Going the wrong way here. Right, and let me see if I can show you this. This is the port forwarding, that looks good. And let's start here. That's a good start. Remember I told you we have this statsd daemon running to export the data for Grafana and Prometheus. That's the app mesh overview dashboard that we have for Grafana. It's basically Grafana. You can define whatever you want. Maybe the more exciting thing is that this is up for 4.5 weeks. So it's not just like one small Minikube demo that I start. I have it running all the time just to see how stable it is. And so far, it's doing really well. And you see like the top 5 services by request per second. You see the worst 5 by HTTP 400 and 500 errors. This is spike when I reconnect. And you see connection numbers and stuff. And that's the service mesh overview. And then we can also go on a service level. And on a service level, I promised you there is this load generator, which is not doing a lot. It's just sending requests like at a very high number per second, and it's doing this since almost 5 weeks. And then you can also switch to the app mesh, to the Nginx app mesh, which is the receiving part. That's what the load script is calling. And you see a little bit more happening, but also not too much. So that's everything you could also get with Istio and Envoy. That's what you get from the CNCF projects, and that's what a lot of people want to see at the beginning. But at the same time, because I have this app, this X-ray enabled, you get a nice service map, which looks a little bit like the Kiali. Let's see if this is loading. And again, you see that's the Nginx. And that's actually the real Nginx. And you see the load distribution, the response distribution in time. Now, if you want, you can also get traces that look a bit like those flame graphs. And you see this is the load generator, which in total takes that much time, which is calling the Nginx, which takes that much time. If you turn this upside down and you change the color from blue to red, you see it's like those flame graphs that Brandon Grech is talking about. And you can have more analytics like seeing the response distribution times, how they change. What's the typical response distribution time for a P50 percentile, P90, P95? Okay, so it's not really that, first of all, you need to decide if you want to use all the open source tools from CNCF or if you want to go to what we give you with AWS X-Ray. That's what I like about this demo now. It's packing everything into one and it's showing you, you just can do it if you want, and then you select the right one, you play with it, and maybe decide later. Right, let's go back to this. So I showed you all this and this and this. And as I already mentioned, the thing is, since it's not Istio, but it's app mesh, there's some new constructs. They're not very difficult. The first one that you need to define is the mesh itself, which is the logical boundary of the network traffic, which can span, from EKS to ECS to on-premise, not on-premise to EC2, if you want. Then we have the virtual nodes, which are the endpoints that you talk to. So that's kind of covering or shielding the endpoints. And then we have routers and routes. And if services talk to each other, they use this virtual service name. So that's new. That's AWS App Mesh specific. And then we work with proxies and services and service discovery. Right. We have a public roadmap. I'm super happy about this. I hope this will take over and happen also for other projects like the managed Kafka service that we do. The container people started. It means it's on GitHub. If you have requests, if you want a new feature, you can open an issue. And, well, obviously we prioritize them, but you can also see what's happening. I think this is a very good start. I try to convince more service teams to do the same thing, at least the ones that deal with open source software. So, to conclude, as a summary, I think you should architect wisely. That's always nicely said, no? What I'm trying to say is don't listen to the people that tell you everything will be Lambda. Don't listen to the people that tell you everything will be containerized. The truth is somewhere in the middle now. It's your job as an architect to find the best solution for your particular situation. And usually nobody can tell you this. We see trends, and if you want to go to high abstraction levels, obviously go to Lambda. There's many reasons why you should use containers, and there's still reasons why you will run stuff on EC2. So that's up to you, and nobody can take this responsibility away from you. Running Kubernetes is hard. Trust me, I tried it. I know people who are really good in operating Kubernetes, but I think most of the people I know, they are not. So use a managed Kubernetes service, unless you really have the knowledge and you think that's your differentiator running Kubernetes yourself. Go for a managed Kubernetes service. EKS is standard upstream Kubernetes. It's unforked. Service meshes, and this is what I was trying to explain in this presentation, they complement Kubernetes, they build on top of Kubernetes. So when I started to look into this, I was questioning a lot. I thought, like, is this something they just forgot in Kubernetes? But it's not. It's really a level on top of Kubernetes. That makes a lot of sense. So it's free to use. It works across compute services. That's maybe something to remember. As I told you, I once did a presentation about Istio and Envoy, the open source part only, if you're more interested in details about this. I mean, there's many other presentations, but that's one link if you're interested in this. And with this, I want to thank you for your patience, for listening to this talk, for bearing the heat. Thanks.